So today we are dealing with cerebrum external features, and we'll be studying it under this introduction, external features, which includes the poles, surfaces, borders, sulci, and the gyri. So this sulci and the gyri will be seeing on the different surfaces. There are the three different surfaces. That's the superolateral surface, medial surface, inferior surface, and later on we'll see which are the different types of the cerebral cortex and the structure of cerebral cortex. So let us begin with, so as we have started with the central nervous system, one part of it is already over, that's the spinal cord. So the central nervous system consists of the brain and the spinal cord. So the spinal cord is present within, and the brain is present within the cranial cavity. So what does this consist of? It consists of white and gray matter. Gray matter is present in the spinal cord, right in the core, and the white matter is present on its periphery. While in the brain, the white matter is present right in the core, while the gray matter is present outside, just the reverse of what it is present in the spinal cord, except in the region of brain stem. Okay, so let us see what are the functions of the brain. So this brain is concerned with receiving information and controlling the activities of limbs and the trunk through the spinal cord. And also it helps in receiving information and controlling the activities of head, neck, and the face region through obviously the cranial nerves. And where the nucleus of it is located? It is located in brain stem. The lower vertebrates actually have all these functions, but in the humans, they have these additional functions. It helps in assimilating the experience with the help of, through which it will utilize the memory and helps in the learning and the intelligence. It is also responsible for personality and the thoughts. To give a better example, so at present you are writing the assignment. So you are concerned with writing assignment and submitting. It's nothing but utilizing your only the motor and the sensory informations. Like human brain, if you utilize your memory and the thoughts, it will be like utilizing the complete use of the assignment. Let us see what is the weight of the brain. So the weight is around 1,400 gram in the male and around 1,200 gram in the females. Don't worry, girls, the weight, it's actually the intelligence which matters. Okay, cerebrum, the brain, actually it consists of the 6 major parts. It consists of cerebrum. In its core, it has diencephalon. So diencephalon, what does it mean? It has the thalamus, hypothalamus, subthalamus, meta, and epithalamus. Thalamus is basically concerned as a relay center for all the sensory information. So what I call thalamus as the PA of a cerebrum. So any information which comes from cerebrum is via thalamus, except for the one coming from olfaction. So the olfactory signals, they do not relay. You can call it as Atmanirbhar. Yes. So the other parts of the cerebrum are midbrain, pons, and the medulla oblongata. So this together we brain stem. And the last part is cerebellum. Now cerebellum is again the one which has its own PA called as a pons. So this pons, it has been set up with its ego. So like how the cerebrum, it gets all this fibers related to the thalamus, the pons, in the pons, all the fibers do not, which are coming to the cerebellum, do not relay. Only for the sake of ego, like the cerebrum, all the fibers which are coming from the cerebrum, they have to relay the pons and go to the cerebellum. And the fibers directly come to the cerebellum. So the fibers, you will name it as corticopontine and pontocerebellar. So as they are relaying in the pontine, so we'll call as corticopontine and pontocerebellar fibers. So those fibers which are going from the cerebellum, from the cerebrum, what you call it as corticospinal, and which are coming towards it, we call it as spinothalamic. So the corticospinal is concerned with those motor signals which are going via the spinal cord into the periphery to the limbs, trunks, while the fibers which are going to the head neck phase, they relay in the brainstem, and you call it corticonuclear fibers. Those are again the motor fibers. Okay, now let us see what the cerebrum consists of. The cerebrum, it is made up of two cerebral hemisphere. You can see these two cerebral hemisphere, which is separated by a median longitudinal fissure. What do you expect along this median longitudinal fissure? What structure will penetrate inside? Do you remember anything penetrating inside this medial longitudinal fissure? It's the falx cerebri. As the falx cerebri is penetrating inside, it will carry along with other folds of the coverings of the brains. Those are arachnoid and the pia mater within this. Okay. Now, each cerebral hemisphere consists of, in this picture you can see, it consists of the outer gray matter. So this outer gray matter, you can see the gray colored part. That's called as the cerebral cortex. And the white matter inside, those are the fibers which are projecting inside. So this is the white matter. And within this white matter, you can see the collection of the neurons. Here you can see the collection of neurons. They are basal ganglia. And this gray matter, what you can see right here, that's the thalamus. It's the diencephalon. So I was talking about this basal ganglia. The basal ganglia is also named as basal nuclei. It is the collection of the neurons, and it includes putamen, globus pallidus, caudate nucleus, and many more. We'll go it in the next lecture. We'll see those structures in the next part. What this basal ganglia is concerned with? It is concerned with the motor, like it brings about fining of the motor activity. It maintains the tone of the muscles, or it decreases the tone of the muscles and removes the unwanted movements. So have you heard about the Parkinson's disease?
Maushi?
In the Parkinson's disease, sorry, something is off your audio right there. Something is audible from your screen. Thank you. Okay, thank you. Sorry for the disturbance. Here we are talking about the basal ganglia. So if the basal ganglia is affected, there will be the Parkinson's disease. So the Parkinson's disease, the patient will be having a fine tremors. So these tremors, they are at the resting phase, and the patient will be having the rigidity. So there will be an excess of the tone of the muscles. And okay, so these were the parts or the structures which are present within the cerebral hemisphere. So I said the outer gray matter is the cerebral cortex, the white matter, then the basal ganglia, and the cavity inside. The brain has cavity, and that cavity is known as ventricles. And this ventricle, it consists of CSF. Within the cerebral hemisphere, in each cerebral hemisphere, you will see it has lateral ventricle. So you can see the C-shaped structure. It's the lateral ventricle. They are in a pair. It has this anterior horn, inferior horn, and this pointed posterior horn. Let us move further with the other features. The cerebrum, it has poles. This is the frontal pole. The one which is on the posterior is the occipital pole, and the other one are the temporal pole. So these are the poles which lie at its end. The surfaces are, you can see from the outer side, this surfaces will be superolateral surface. So the superolateral surface looks like this. This is the superolateral surface. medial surface. So where do you expect the medial surface? If you cut the cerebrum into two pieces, into each cerebral hemisphere, right in the midline, you can see it is connected with this commissural fibers called as corpus callosum. And this is the medial surface. Here you can identify its anterior pole called as frontal pole. This is a posterior pole, and posterior towards the posterior pole, you can see there is a cerebellum. And important features in this medial surface is it has this C-shaped structure called as corpus callosum. This corpus callosum consists of commissural fibers. So it has white fibers which joins the same area of the different hemisphere. So two different hemisphere which has this. Further, you can see this corpus callosum, it has the bended area and this pointed area. This pointed area is called as rostrum. This bent area is called as a genu. And this is the body, and the last one, the larger part, is called as a splenium of a corpus callosum. Further, beneath this, you can see something, the violet color structure right here. It's the thalamus, and the lower part is hypothalamus, and this part is a brain stem. So in this medial surface, you will see following structures. Only point to remember is to locate out its anterior end and the posterior end. Let us move further with inferior surface. The inferior surface is divided into two parts. This part, which is a smaller one, is called as orbital surface. This larger part is called as a tentorial surface. And this two surface is divided by this lateral sulcus right here. You can see there is a lateral sulcus which divides this into two parts, the orbital surface and the tentorial surface. So this is all about the surfaces. So the three surfaces which I mentioned was superolateral surface, medial surface, and inferior surface. Let us come towards the border. This border right here is, just a second, the border right here is the superomedial border. This superomedial border divides the superolateral surface from the medial surface. The other borders you can see right here in the inferior surface. Along this inferior surface, the borders which are seen are, what do you expect this border as? This will be inferolateral and this will be a inferomedial. But it is not named so because the inferior surface are at the different planes. The orbital surface is slightly lower as compared to the tentorial surface. So the borders, they are renamed as the superciliary border along this orbital surface and inferolateral border along this tentorial surface. So the tentorial surface separates, so inferolateral border separates tentorial surface from superolateral surface, while superciliary border separates orbital surface from superolateral surface. Okay. Now let us come to the other borders. Right in the midline, you can see medial orbital border, hippocampal border, and medial occipital border. How to remember this is, this is right in the medial, so midline. So you can call it as medial. This separates the orbital surface. So this is a medial orbital border. Here in this area lies the hippocampus. So the border which separates it is the hippocampal border. The border which is separating along its posterior pole is called as a medial occipital border. So these are the different borders which are present along. Let us move further with sulci and the gyri. So you can see the brain has a larger surface area. The cerebrum has a larger surface area. It is around 2000 square centimeter, and it has to accommodate within the cranial cavity. So as the space is limited, so this has to produce some convolutions. So foldings. So the foldings which are produced by the cerebral cortex is like this. So the indentation which is produced will be called as gyri, while the depression which is produced is as a sulcus. Sulcus vary in a depth, which could be a slight grooves or to the deep fissures. They are classified according to their functions as limiting sulcus, axial and operculated. Limiting. Limiting is the one which limits. So it limits motor area from sensory area. So one of the sulcus which limits it is the central sulcus. It has the limiting sulcus. One more sulcus which is called as the axial sulcus. Axial sulcus it runs along the axis of the posterior pole. So the axis for here, for the cerebrum, like there is a visual area along this occipital pole. So along this occipital pole lies one sulcus which acts like an axis. So name of that sulcus is post-calcarine sulcus. It will be along the axis of that visual area. So is the name axial sulcus. Operculated. Operculum means lid-like, lid. So there is a sulcus called as lunate sulcus. The lunate means moon shaped. So the lunate sulcus, it separates the visual area or striate area from parastriate area. So along the walls of the sulcus lies the parastriate area. So it separates the striate area from parastriate area like a lid. So it is called as a operculated. So to give examples, again I repeat, the limiting sulcus is the central sulcus because it limits motor from sensory. Axial is which will lie along the axis of the visual area. So the axial sulcus is post-calcarine sulcus. The operculated sulcus is lunate sulcus. Now, depending upon its development, it is named as primary and the secondary. Primary is the one which is present since birth. Central sulcus is present since birth. Secondary, which appears later on. So there are many other like lateral and other sulcuses. They are secondary sulcuses. Okay. Complete and incomplete sulcus. The complete is the one which produces indentation within the cavity inside. Which cavity is present in the cerebrum? That's the lateral ventricle. So the sulci which produces the indentation within the lateral ventricle are called as complete sulcus. One of the example is collateral sulcus, the complete sulcus. Others are incomplete, which do not produce indentations. Okay, now let us move further with the gyri. So gyri are nothing but the convolutions. You can see these convolutions. They consist of the outer gray matter and the core of the white matter. The gray matter will be surrounding this core of white matter. Now let us see further the different. Let us see further the main cerebral sulci. First, we'll begin with the lateral sulcus of the sylvius. So this lateral sulcus of the sylvius is located right in the deep cleft on the inferior surface. So here you can see the one which is marked with the red. It is located in this deep cleft between the inferior surface of the cerebrum and the temporal pole. So here, right here. So along this cleft lies the stem of the lateral sulcus, and this lateral sulcus, it reaches to the periphery or to the superolateral surface. The point where it reaches the superolateral surface is called as sylvian point. Further, from this sylvian point, it gives three rami. One of the major rami which goes posteriorly is called as posterior ramus, and other two ramus which ascend. So here you can see the lateral sulcus. This continuation is the posterior ramus here, and the other two ramus which ascends on the anterior side are named as anterior horizontal and anterior ascending. Horizontal is the one which runs horizontally or in a transverse manner, and the ascending, it runs vertically. So this one. So these are the three rami which are present. Let us move further with the other sulcus, the central sulcus of Rolando. The central sulcus of Rolando is present in the midpoint, somewhere in the midpoint of the length of the cerebrum. So here you can see there are three more lines which are running parallelly right in the midpoint. So out of this, you have to identify which is the central sulcus, the one which is lying on the superlateral surface, and it cuts the superomedial border and produces some indentation, or it produces some sulci on its medial surface, is the central sulcus. So this we'll be seeing in the brain itself later on when I share you with the video of the sulci and the gyri. Okay, this is about the central sulcus. This central sulcus, the front of it lies some area, and I said before the central sulcus is the limiting one. So it limits the motor area from the sensory area. The motor area is somewhere here, and the sensory area is this. This is the limiting sulcus. Next comes the calcarine sulcus. The calcarine sulcus is located on the medial surface. Okay, here. So the calcarine sulcus is located on its medial surface. So here you can see the calcarine sulcus. The calcarine sulcus, it begins right from the splenium. So I said this is the corpus callosum. So it has this genu and this is splenium. So it begins behind the splenium of the corpus callosum and runs on its medial surface, and it cuts the superolateral surface slightly on the superolateral surface. And I said before, this post-calcarine sulcus acts as which type of sulcus? It is running along the axis. So it is axial type of a sulcus, post-calcarine sulcus. Next comes the parieto-occipital sulcus. The parieto-occipital sulcus will be running along the medial surface. So how to identify it? Look for the calcarine sulcus. It cuts the parieto-occipital sulcus, cuts the calcarine sulcus right in the midline. So it cuts it and runs on the superolateral surface. So these are the few main cerebral sulci. Okay, now knowing this major sulci, we have to divide the cerebral hemisphere into the lobes. So the major sulci here, we know the central sulcus, the lateral sulcus here, and parieto-occipital sulcus. Draw two major imaginary lines running from this parieto-occipital sulcus to the preoccipital notch. You can see here there is one notch called as a preoccipital notch. Draw an imaginary line. Draw one more imaginary line joining this the first imaginary line. So this way we have the cerebrum which is divided into this four lobes. This lobe is the frontal lobe which is in front of the central sulcus. This lobe is parietal lobe which lies between central sulcus and the first imaginary line. This lobe is temporal lobe, and the last one, this one is an occipital lobe. Thus we have these following lobes. Apart from this, there is one more lobe which is hidden within the cerebral hemisphere, and that's called as insular cortex. So you can see if you raise the lip of this lateral sulcus, you can see the hidden cortex called as insular cortex, also called as island of Rhea or a central lobe. The peculiarity of this is, so it has a sulcus around it called as a circular sulcus and a space separated from here called as a Lyman insulae. This cortex is divided into two parts by one sulcus, sulcus centralis. This large sulcus called as sulcus centralis into the smaller area and the larger area. And it has a gyri, sorry, it has the, gyri. The large, you can see the gyri here, they are longer. So they are called as a gyri longus, and this gyri, they are the shorter. So you can call it as gyri brevia. Brevia goes for short. Gyri brevia and gyri longi. Okay, let us come to the main part of the cerebrum. That's the sulci and the gyri. We need to know each and every sulci and the gyri of all the surfaces. So let us begin with the sulci and the gyri. The main sulci and the gyri we have studied are the central sulcus, lateral, parieto-occipital and calcarine. On the superolateral surface, Along its frontal lobe, there are few more sulcus. The sulcus which is running parallelly is called as the precentral sulcus. So this sulcus is in front of central. So it is precentral sulcus, and the gyrus which is in front of this, so it is called as a precentral gyrus. And what I said was precentral gyrus is concerned with motor activities. So this area of a brain is concerned with the movements of the body. This is concerned with it. That's area number 4. It's a precentral gyrus. Apart from this, the sulci and the gyri which are present on the frontal lobe are the horizontally running two sulci, that's the superior frontal sulcus and inferior frontal sulcus, which divides this area into the 3 gyrus: superior, middle and inferior. Easier? So it's the superior frontal sulcus, inferior frontal sulcus, and superior frontal gyrus, middle frontal gyrus, and inferior frontal gyrus. Point to note, along the inferior frontal gyrus, we have the 3 rami which are projected from the lateral sulcus. This rami which is running along the anterior side was called as an anterior horizontal and anterior ascending. It occupies these 3 areas called as, the area number A which I have mentioned here is pars orbitalis. Now I expect why orbitalis, because the next to it lies the orbital surface. So it's a pars orbitalis. The area here which is named as B, which is present between these 2 sulci, is pars triangularis. The pars triangularis goes with the triangular area, and the area which is left on 10 minutes. Okay, okay, fine. So the area close. So the area which is left on the posterior side is the area C, which is called as the pars opercularis. So we have 3 areas: pars orbitalis, triangularis, and opercularis. So now let us see the area or the sulci and the gyri along the parietal lobe. So you can see there is one more sulci which is running vertically. It's the post-central sulcus, and the gyrus which is occupied here is post-central gyrus. Parietal lobe, rest of the parietal lobe is divided by this transverse line, and it's called as an intraparietal sulcus, and divides this parietal lobe into supraparietal lobe and inferior parietal lobe. And within this inferior parietal lobe, there are 2 more indentations or 2 more gyri which are produced by the rami which is extending from here. So this rami is the posterior ramus of lateral sulcus, and one more sulci which is coming from the temporal lobe. So this gyri which has been produced is supramarginal gyrus, and the other one is angular gyrus. These 2 area number 39 and the 40, they are concerned with the speech. So sensory speech area is concerned with this. The Wernicke's speech area or the sensory speech area is concerned with this. Now let us come to the temporal lobe. There are 2 more sulci. How will you name this as? The one which is above and one which is below along the temporal side. So you call it as superior temporal sulci, inferior temporal sulci, and the 3 gyri will be named as superior, middle and the inferior temporal gyrus. Okay. Now let us come to the occipital lobe. Along the occipital lobe, the major sulcus which has come like an axis from the occipital pole is a post-calcarine sulcus, and I said before, this post-calcarine sulcus acts as the axial sulcus, and surrounding this the moon-like area called as a lunate sulcus. This lunate sulcus is also called as opercular sulcus because it acts as a lid which hides the other area, that's a parastriate area. The other sulcus which is running here is called as a lateral occipital sulcus. So this is all about the superolateral surface. So these sulci and the gyri you see on the superolateral surface, you need to know the names of each of this. Now let us go with the sulci and the gyri on the medial surface. So medial surface, I said the easy way to identify is look for the corpus callosum which is present in a cut section. This is the anterior end of this corpus callosum. The pointed end is called as a rostrum. Rostrum means beak-like. The one which is like beak is a rostrum. The bend is the genu. So all the bend we call as a genu valgum, and the splenium right here. And even along its anterior side of the cerebrum, you can see it has two poles. You can see the frontal pole and this is occipital pole, and the pointed frontal pole and this temporal pole and this pointed occipital pole. Let us go with the sulci and the gyri on the medial surface. Above the corpus callosum, the sulci which is running parallel to it in a C-shaped manner is the cingulate sulcus, and the gyrus enclosed within it is cingulate gyrus. This area, you can see two more sulcus. They are called as a para-olfactory and the para-terminal. So this is an anterior para-olfactory. This is posterior para-olfactory sulcus, and the two gyri, they are called as a para-terminal gyrus and para-olfactory. Why the name para-terminal? So this area is called as the lamina terminalis. It terminates something here, lamina terminalis. And surrounding it, gyrus is called as a para-terminal gyrus. Para-olfactory gyrus, here the olfactory part is concerned with. So it's a para-olfactory gyrus is located right here. The other sulci and the gyri which are present, here you can see the sulcus which is present surrounding the corpus callosum is called as a callosal sulcus. And these cingulate sulcus, it gives two offshoots posteriorly, and it encloses one gyri called as a paracentral lobule. So this paracentral lobule is concerned with defecation and micturition reflexes. So it is concerned with this paracentral lobule. So posteriorly, here we have the two main sulcus, the calcarine sulcus, and I said how to identify the calcarine sulcus. Just posterior to the splenium, it runs and it cuts the occipital pole to extend for a smaller distance on superlateral surface. That is the calcarine sulcus. And parieto-occipital sulcus, which is present right in the midline of calcarine sulcus. Now, can you see here? It has divided this medial surface into two parts. This triangular one, is called as a cuneus, and the quadrangular one is called as a precuneus. The cuneus is triangular and precuneus is the quadrangular one. Okay. Now let us see the other sulci and the gyri which are present. The front part of it is called as a medial frontal gyrus. It is a frontal lobe and it is on the medial side. So it's the medial frontal gyrus. Here, right here in the temporal lobe, there are sulci which are running. So you name it as lateral occipitotemporal. It is running from occiput to the temporal. So it is called as the lateral occipitotemporal, dividing into two gyri, medial and the lateral occipitotemporal gyrus. Further, the sulcuses which are running along this horn-like structure. This horn-like structure is called as uncus. Surrounding this is called as a rhinal sulcus, and the one which is running parallel to it is called as a collateral sulcus. So this is rhinal sulcus and the other one is collateral sulcus. The area which enclosed within this is the uncus and parahippocampus. The hippocampus is located at this area. So uncus and parahippocampal gyrus. The small part which connects, which is present between splenium and calcarine sulcus is called as isthmus. So next I will talk something about the cortex, like the one which is older cortex phylogenetically, and the other one which is neocortex. So the older one is the hippocampus, this one. And the newer one is neocortex. The surrounding cortex is neocortex. And this is the isthmus which connects the cortex with the cingulum. So here you have the cingulum. So that area is the intermediate one, cortex. So thus we have the three different which I will speak later on. Now, let us move with the sulci and the gyri on the inferior surface. Along the inferior surface, we have these two inferior surfaces, orbital surface and the tentorial surface. Uh, So we have done with the sulci and the gyri on the superolateral surface and on the medial surface. Let us continue with the sulci and the gyri on the inferior surface. And as you know, the inferior surface is divided into two parts as the orbital surface and the tentorial surface. This orbital surface, the sulci and the gyri which are present, you can see there is a olfactory sulcus. Why we call it as a olfactory? Olfaction. So there is a olfactory nerve which is located right here. So the sulcus which is present right beneath it is the olfactory sulcus, and the gyri which is present medial to it is the recti gyri. Now guess why recti? As it is straight. So the recti gyri, and the remaining part of the orbital surface is H-shaped sulcus. H-shaped sulcus. The H-shaped sulcus will be dividing this area as anterior, you can say as this orbital sulcus. So this is anterior orbital, posterior orbital, lateral orbital, and the medial orbital gyrus. Okay. Now let us come towards the Now let us come towards the inferior surface, the tentorial surface. You can see along the tentorial surface, this the rhinal sulcus. I have already covered it in the on the medial surface, a few point of it. As the medial surface also shows this, but particularly on the inferior surface, you need to comment this, because when you invert it, you clearly see this sulci and the gyri. So the sulcus along this is the rhinal sulcus. Rhinus means for the nose. It's nose-like. So it a hook-like thing. What you can see here is the uncus, and surrounding it is the rhinal sulcus. This is called as collateral sulcus. It is running parallel to the hippocampus. So it is called as a collateral sulcus. Let me tell you, the collateral sulcus is again the one which produces indentation in the lateral ventricle. So what you name this, which you will put this sulcus as? This collateral sulcus will be put under the complete sulcus, as it produces indentation. The other sulcus right here is the occipitotemporal sulcus, dividing into medial and the lateral occipitotemporal. Okay, that's all about the sulci and the gyri on the inferior surface. Let's see the different types of cerebral cortex which is present in the brain. The cerebral cortex has been divided into three parts: archicortex, paleocortex, and neocortex. The archicortex is the one which is phylogenetically oldest. The older one is the archicortex, and it is made of layers. So one of the example for the archicortex is hippocampus. And where the hippocampus lies, I have shown you that it lies on the inferior surface. So I will. So the next cortex, what you see here, phylogenetically the intermediate in origin, that's the paleocortex. That's the cingulate gyrus. So where do you expect the cingulate gyrus? I'll show you in my previous picture. So here you can see the hippocampus is located right here, and cingulate gyrus is located right here. And I said there is something called as the isthmus which is located here. So the cingulate gyrus, The hippocampus, which I said as an archicortex, is the oldest, phylogenetically oldest, which is made up of 3 layers, is located here. It connects this intermediate one called as a paleocortex through the isthmus, and the remaining part of the cortex is called as a neocortex. And the neocortex, it has this following layer, just a second, yeah. It has this 6 layers and it occupies around 90% of total area of cerebral cortex. Now let us see what are the different layers which are present in cerebral cortex. Before that, the cerebral cortex is nothing but, I said it's the gray matter. So the gray matter means the one which includes all the nuclei. Which are the different types of the nuclei present within the cerebral cortex? So you can see there are the pyramid shaped cell. So this pyramidal cell is present, and we know the corticospinal tract is called as a pyramidal tract. It's named by this the shape of these cells because they arise from these cells, pyramidal cells. And what do this pyramidal cell does? Like it carries the fibers, the axons of it carries the fibers towards the spinal cord. So it is carrying the motor fibers, the pyramidal cells. The other cells which are present are stellate cells. Stellate is star shaped. It is also called as the granular cells. And these granular cells, they produce a dusty appearance or a dusky appearance or cloud-like appearance within the cortex. And so the cortex, that area is also called as coniocortex. So that area which have the granules or granular cells, also called as stellate cells, are called as coniocortex. Let me tell you, in the region of the motor or the cerebral cortex having the motor area have a large number of pyramidal cells, and the one which is having the sensory area has a large number of stellate cells. The other types of cells which are present are horizontal cells of Kajal. It's not Kajal, C-A-J-A-L, it's a Y is a silent, it's a Kajal. The horizontal cells of Kajal, they are the outermost layer which is running horizontally. It's forming the molecular layer. The other one are fusiform. You can see the fusiform which is seated deep in the cortex, the fusiform layered cell, and the cells of Martinotti. So these are the different types of the cells which are present within the cerebral cortex, and it has this following layers. The outermost layer is called as molecular layer. Next comes the external granular layer. Molecular layer consists of the cell called as the horizontal cells of Kajal. And the next layer is external granular layer. Obviously, the stellate cells or the granular cells will be located here, but densely or compacted within this. Next comes the layer of small and medium sized pyramidal. So you also call it as external pyramidal layer. The pyramidal cells present here, they are smaller in a size or medium sized. The next layer comes inner granular layer. Again, the stellate cells are located, but they are closely packed. Important point to note in this layer, the layer number 4 is the white fibers, they are arranged horizontally and they produce a stria within this. And they are mostly present along the visual cortex, where that cortex is also called as striate cortex because it's grossly appeared as a striated because of the white fibers which are running horizontally. Next comes the ganglionic layer, which is the layer consisting of pyramidal cells, larger pyramidal cells, and they carry the motor fibers. Next comes the multiform layer, where the number of layered cells are present, and they are called as a layer of polymorphic cells. Now, how to remember the names of these layers? I have highlighted the names P, G, P, G, GP. It's like you try for PG, again you try for PG, and you don't get any PG, then you do GP, general practice. So it's the mnemonic for it. Plexiform layer, granular layer, pyramidal layer, granular layer, ganglionic layer, and polymorphic cells. And then goes the white matter. This is all about the external feature of cerebral cortex. So we'll end with this topic. Thank you. So
if you have any questions, you can unmute yourself and ask.
If you have any questions, you can unmute yourself and ask. You can type